Welcome back to the Accidental Telescope Factory. It's an exciting day. We're finally going to build the OTA. So let's go have a look at the CAD and see what we got. You want to say hi to everybody? Come here. Come here. Up, up, up. Oh yeah. We're going to be focusing just on the OTA. And this is the visual configuration. You can tell by these trunnions, or the the altitude bearings. Okay, Java. Oh wow. We're looking at these altitude bearings here. It can very accurately and smoothly orient on the stars, because this is a very long lens, essentially, like a very long lens, and it's very sensitive to motion. You need to have very, very precise motion, and that's what these trunnions do. So now this is what we're going to build today. Here we've got our dust cap, and its little plugs that go in it to allow it to be a Bahtinov mask or an aperture mask. The focuser we built in a previous video, so that's the focuser here. And we will be attaching that today as well. Let's start building. Let's turn on our soldering iron. We're going to do a bunch of big heated inserts. We're going to put to 275. And there we go. And we're just going to get started. Okay. So first we always check our list to make sure that everything is here. If you bought one of the 10 telescopes kits, you're going to have a big bag of hardware, lots of goodies in it to do the build. The main thing we'll need today are these large heated inserts. We can do one of two of these mirror cell housings. So one is just plain, and depending on how much hardware you think you'll put at the eyepiece, if you think you'll be putting like a heavy phone or some other type of camera, maybe a DSLR camera at the front, you may want this version. It allows for more D-cell batteries to be placed as counterweight at the back end to counterbalance anything on the front. I think we'll actually do this one with the extra counterweights. For your information, it always goes in with that little narrow nose first. Okay. Oh, here we go. Gotta break this up. Okay, so now we're going to take this spider and we're going to mount it inside the spider enclosure. And actually, we will need the soldering iron on for this. It doesn't have to be too hot though. Yep, that's fine. Okay, so the first thing we're going to do is we're going to look for, there's an arrow. Can you see the arrow on the surface here? We're going to take that arrow and we're going to orient it so that it's pointing at this red dot finder dock up here. And we will have broken out, sometimes there are some tabs on this spider that are part of the printing process. We'll break those off. They're very easy to break off, but we'll break those off first. Okay, now we orient this. Now this is a bit of a tricky step. Well, sometimes it's tricky because you have to put it in straight. Otherwise, if one vein of the spider gets ahead of the others, then the first one won't go in. So now we just sort of do these two, and then we do these two, then we do these two, then we do these two. And if everything with the printing and everything has gone well, they should be very flush with the surface. You see, very flush here, very flush up here. So when it's flush, then you know, because the next step is kind of permanent, what you're going to do. And this is also if your shrinkage and all your print setting, you're not over extruded. If your printer is very nicely calibrated, then this next step will be necessary because that spider could fall out again. What we'll do is we'll just weld across. We'll make these little stitches where the plastic of one piece is kind of welded across into the plastic of the other. I don't know if you can see what I'm doing there or not. You can see I'm welding it across. Another fun step is to knock out this support here. It's really just a printer artifact. One thing I don't like to do is I don't like to have it right up against the table. So I'll kind of hold it in midair so that the shock won't damage the actual housing itself. You can just take a hammer or a mallet and just kind of go. Just fall right out of there. The next step is to do the same thing for this upper baffle. So do the same thing here. This PETG is pretty tough actually sometimes, so you have to What you can do is you can kind of work your way around with a knife if it's too stubborn. Okay. There we go. So now that that's out, we can match this hole with this hole. Just slide it right in. And it will just slide right over. Another somewhat satisfying step is to have some 10mm by 3mm magnets. So we'll have these 3 magnets. Take one little magnet and look for a slightly ribbed surface. Kind of tuck it underneath the ribs and then pop it into place. Do that 2 more times. Now we're going to put on our focuser. So here's the focuser we made last time. I've already put in these M5 by 75s. So, and now you can actually get a little preview of how the tilt correction mechanism works on this. So these grub screws that we put in here before will actually press up against these magnets here. Okay, so now orient it correctly, line it up with those holes, and you don't have to put them all in at once, but once you get one in, then the others should line up fairly easily and fairly well. Just sitting in there loose for now, but if you look on the inside, oops, more pieces than we know what to do with. If you look on the inside here, you will see where these little M5 screws are coming through. So for that, what we need are M5 nylock nuts. We'll put it in so that dome side of that nylock nut is pointing away from the focuser, away from the screwdriver, as it were. Again, we don't have to over tighten these. And you'll find that there's just a little recess in there where the nut goes. Again, dome side away from the screwdriver. Okay, and now we've got those on there, and oops, you see all the nuts inside there. holding it together. Okay, now is the first of our pre-collimation steps. So you can use a 2-inch collimator or a 1 1/4 inch collimator with an adapter. So we'll insert this in here. Right now we only have 1 thumb screw. We will seat this right up against there. Okay. And now what we can do look at how that red dot is lined up with the hole back here. In this case, we can see it's a little bit high. Ideally, it will come right out the hole on this side. Now we can see it start to come through. Collimation hole. It's starting to come through all the way, but it's not fully. It needs to go down a little bit. Okay. Okay, this is our secondary holder. First thing we're going to do is put some magnets in here. Once again, we use 10mm diameter, 3mm thickness rare earth magnets. And we just snap them in, similar to what we did before. For the rib side. Sometimes they're stubborn. Okay. All right, the next step is going to be to mount our secondary mirror. This is 70mm, so quite a large mirror. You don't have to use such a large mirror. For visual, if you know it's going to be purely a visual scope, you can go for a smaller mirror, maybe 60mm or even 55, something a bit smaller. Will give you more contrast, but if you're going to move towards astrophotography, you'll get more vignetting with a smaller mirror. So I kind of tend towards the larger mirrors just in case somebody wants to try a DSLR over time. But anyway, we're going to put a 70mm mirror on today. And one of the things we're going to do is we're going to use mounting tape on this surface to mount this mirror. So what we want to do first is make sure our mounting tape has got an ability to get some good purchase on. So I've just got some 80 grit sandpaper. I'm just going to scuff up this surface. And just make sure that the mounting tape has got something really good to grip onto. And we'll just wipe off any dust. All right. So you can see that we've scuffed that up. Maybe we could scuff it up a little bit more up here, maybe. We're not trying to win a beauty contest here. We're trying to create a surface that our tape will really adhere to. Okay, so next step, we take the ball. We're making sure that that heated insert's already in there. Drop it in. Now we'll need our 3M double-sided mounting tape, and we're going to put that on. We're going to leave the red backing on here because we don't want it to stick on that side yet. We just want it to stick on the first side. And we're going to just line it up with the outside edge over here. And then we will come along with a knife. And we'll just cut it a little bigger than we need it to be. All right. Okay, so here's what we've got so far. Now we're going to trim off all the excess around there. We're going to try and trim it off as cleanly as possible. And you see we left that, Hi Java. What's up? Okay, you want a little break outside? Okay. Okay, so now what we're going to do is we're going to trim around nice and cleanly. There we go. Let's see. We're doing along here, trying to create a nice clean edge. Sometimes you'll get a little bit, some little boogers like that, and you can just clean those off with your knife. That looks pretty good. Okay. So now, you're here? Okay. So now it's good to just kind of practice what it's going to look like. So you can see here the way that there's like an angle cut on this. So the angle, I still have this non-adhesive protective surface on here. Just kind of to practice and familiarize yourself with what it's going to look like. You'll line up that little rim, and all these angles will sort of match up with each other, right? So now we can peel off this backing. And sort of practice your positioning. Keep the front of this mirror on the protective surface of this tissue paper. And now we can peel this off. So now what we'll do is we'll place this more or less just leave it lightly on at first. Okay, that's not perfect yet. You have some opportunity to remove it. So there's about 1 millimeter at the top and bottom. Then once we feel like we've achieved correct position. You can kind of look around the edges. Make sure that you kind of have an even spacing. You know, plus or minus a millimeter is probably fine. If you can do better, then great. And then use the tissue that the mirror shipped with and just press that mounting tape in place. But it doesn't hurt to do. You just kind of straighten up that ball so it's going to be easier later. Oh, let's use something smaller. You can kind of straighten this up so that later on when you're mounting it, it's not going to be devilish. So that's reasonably straight now, so it shouldn't be too hard to get it to stay in place. Okay, and so we're trying we don't want to touch the nice shiny surface of our mirror. Okay, next step. Here's our rotation collar. And we're going to put some M3 by 12s or M3 by 14s into our heating inserts. Okay. That looks good now. Yeah, that looks good. Okay. So there's our rotation collar with the 2 screws in it. Now we're going to place some M3 by 20s in here. Now the idea of the rotation collar is that when we have these M20s in here, they can tilt this way, so we can tilt the mirror, but when we try to move it in the rotation direction, we don't have the same motion. Okay, so that goes there. And then so now that we have this kind of pre-assembled, you can see that. Let's try to view it from this angle. You can see that the mirror is able to tilt, but in terms of the rotation, these 2 components are locked into each other. So this is how we end up separating. So you can see we can tilt, but we have no rotation ability. So that's the idea of separating rotation from tilt. Okay, so now that we have these completed, we're going to find our M5 by 75. M5 by 75. And that's going to go right up through the middle hole of the spider. Right? And now, you should be able to just start it by hand. You want to keep in mind that this secondary mirror is going to be, this secondary mirror is going to be on an angle so that the light is reflecting along the path of the focuser and towards the primary. So now we can bring this up through here and right down that middle hole. We want it to grab, so let's have a look from the front here. So we just put an M5 by 75 in there, and it goes through, and it's grabbing onto that secondary mirror, like that. Okay. And now you can see that we can rotate the secondary, and we can also tilt it, right? Okay, so that's good. So it looks like maybe we've over tightened that a bit. That's okay. We don't want it to fall off. All right. So now you'll need some M5 by 60s. And these will each go into here. Okay. Now, according to our drawing, we want to have about 6 millimeters. So we'll get our handy dandy metric measuring device, but we're basically measuring between the surface of the spider and the inside surface of that screw. It should be 6 millimeters. And right now we've got, let's see here, we've got about 6, 7, yeah, we've got about 7 on that one. Okay. So I don't know how well you can see that, but all this space in here is about 6 millimeters for all 3 of these, right? And the closer you are, again, the easier it's going to be to collimate later. Okay, so now that those are all correctly in place, now what we can do is we can tighten this center one until we feel, so right now you can probably see this is still loose back here. We're going to tighten it until that secondary holder is no longer just moving loose. All right, there we go, right about there. Nice, okay. And now would be a good time, before you tighten it too much, you can look and you can see these little rotation set screws back here. Probably see it right there. That screw right there. We want it to be lined up with the vane of the spider. So if you're looking right down it, see that that little screw shouldn't be peaking on that side. It shouldn't be peaking on that side either. We want to center it right behind the vane of the spider. And there's 2 of those screws. So once they're roughly in place, then you can tighten the you can tighten them down. Okay, seems about right. So, Once again, if this center screw is loose and you can't rotate this, okay. Now it seems like during all the excitement, my screws are no longer lined up with the spider vanes. See that they're just slightly off. And you might have to do a little bit of rotation adjustment later, hopefully not. But just again, the closer you can get in this pre-collimation steps, the better. Okay, so now is our fishing line trick. Now we're going to do another pre-collimation step, which is we're going to take some fishing line and we're going to thread it through our very special 10 telescopes pre-collimation step. So what you'll notice are these little nubs here, and they have little holes beside them. Now the first thing we'll do is we'll make sure that each one of these, there's like a groove down the middle of each of these. So I don't know if you can see that. Essentially, what I'm doing is making sure that each of these, just making sure that each one of these is open to take a fishing line. There's 3 on the top and 3 on the bottom. So we'll do these 3 as well. And sometimes the 3D printer, I mean, there's supposed to be a groove there. It's designed that way. Sometimes just little boogers or 3D printing boogers get in there and they make it difficult. So we open those up. So hopefully, if your 3D printer did a good job, there should be nothing stopping you from threading it through these holes. It'll come right through. Try not to touch the mirror. Well, you can touch the mirror with a fishing line because it's not going to cause any problems. But thread it through and then into the hole on the opposite side. Alright, we get it on that anchor point there. And then we can find another little piece of adhesive tape. And now that all the fishing line is tight, we can just adhere it into place. So now you can see, so if we want to bring that mirror to match that fishing line, ultimately what you want is to have the reflection of each of these strings where you can see a gap. You want to see a double string. You want to see the reflection of the string in the mirror without touching itself. And that way you know that the mirror is extremely close to its perfect position without actually going past it, as long as there's a gap along the length of each of those strings. Okay. And yes, it should be a little bit offset. All right. So that looks quite good. Now we'll just verify that our rotation is still correct. Yep. Yep. Rotation still looks good. And that the center screw it shouldn't be overly tight, but it should be so tight that that mirror is not going to move. And you can just do you can just grab the back of the secondary mount and just give it a little wiggle. And it shouldn't feel loose. It's okay if these veins, the spider veins, flex a little bit. That's okay when you try and turn it, but the whole thing shouldn't feel loose. Okay, very good. So pre-collimation step complete. So now we'll just leave the fishing line on there for now because it's easy to remove later. Okay, so now using the collimating laser, we know that our focuser is on axis. And using the fishing line test, we know that our secondary mirror is on its perfect plane. And just by virtue of the design, if we did a good job positioning the mirror on the secondary holder, we know that the secondary mirror is also on axis. So very good. Let's go to our mirror cell. Let's put our fan cover mount onto our mirror cell rear cap. This, we're not actually going to put a fan in this version because this is sort of the light version. Oh, actually, one of the other things we can do, we can knock these out. Knocked out all of these little supports in here. That's a counter bore so that our screws have somewhere to go later. Okay. So now we're going to put these M4 nuts together with this fan and our M4 by 35 screws. Suppose we don't need the fishing line anymore. So what we'll do is we'll just place 1, 2, 3, 4, and we'll orient that with these 4 holes here. 1, 2, 3, 4. Two. So now we will align these 4 screws of this fan cover with the 4 holes here. Okay, so now you can see 1, 2, 3, 4 nuts. Okay, great. Now we're going to mount a mirror in this mirror cell. Okay, so once again we'll need our sandpaper. Here it is. And it's good just to scratch up all the surfaces where we're going to use mounting tape. So right now, just inside these little puck pockets in here, because we are going to put these little shear pucks inside of these little puck pockets, but we're putting them in with mounting tape. So the first thing we're going to do is just kind of scrape up the surface inside of the puck pockets. So I don't know if you can see that or not, but we've kind of scratched up that little puck pocket there. Okay, so we'll scratch them all up. Okay, so now we're going to roughen up the surface of these TPU pucks. You can use whatever you can find that'll kind of mark it up and make it a little bit rough. The TPU is pretty resilient. It doesn't like to be marked up. But essentially, if you can just kind of do it so that you can see the little scratches, then that's, if you can see it, that's something that the tape, the mounting tape can grab onto. So let's just mark these up as best as we can. Okay, so these are slightly roughened up a bit. You can kind of see how on the raised parts it's roughened up. Okay, so now we're going to put some mounting tape on each of these, and then we'll trim it back off again. So each one of these, we'll just get one piece of mounting tape. And then we'll cut it off. Okay, so I've kind of got all three of them kind of on their own single piece. Get my sharp knife. And cut it away from the roll first. All right. Away from each other. Okay, so now I can trim off corners of that. And the cleaner you do it, the better it's gonna work. Now we have these 3 pucks with 3M tape on one side. And now we'll do the same thing on the other side. Okay. So there's our TPU pucks. And you'll just go around, and you can see, maybe you can see, at each one of these little springs, there's like a little support booger there. So now the springs will still be there. The spring will still be there. You can feel it's a little bit springy, but the booger underneath it has been removed. All right, so now we can just remove one side of this non-adhesive backing. And place that puck inside the little puck pocket, right? Sticky side up. There we go. All right. Put it in the puck pocket. All right, good. All right, we still have audio, good. Okay. Now, we'll get our 8-inch, actually, it says 8-inch on it, it's really 200 millimeters, so I'm not too sure why they do that. GSO's 6-inch mirror is actually 6 inches, but their 8-inch mirror is 200 millimeters, so it's a little confusing. But in this case, this is not actually an 8-inch mirror, it's a 200 millimeter mirror. All right. And out it comes. All right. So, the one thing that we have to keep in mind is if there is not a collimation triangle marker on your mirror, then we'll have to make one using a Sharpie. And that's what this little circle here is all about. You can put a Sharpie in there and you can trace a little circle on the face of your mirror if you don't have a collimation triangle. But these mirrors do have collimation triangles on them. All right. Here's our mirror. Now, we can see here that we do have a little collimation. Actually, it's a collimation circle in this case. So that's fine. We're going to protect our mirror. We now know that we don't have to use this circle to mark this mirror's collimation spot. Okay. So now, what we're going to do is we're going to peel the adhesive off. Oops. Okay, now we can take our tissue that we got with our secondary mirror and we can lay it flat on the table. Make sure that there's nothing that can stick to the mirror. Okay, now we've got the adhesive exposed. We're ready to put it on to the mirror cell. So actually, a good step is to put on some cotton gloves. Mirror. turn it over, we'll put it onto this optical tissue to protect the front surface. Now, these centering springs here will guide us into making sure that the mirror is centered. And we can just kind of wiggle it around as we put it down. And we can kind of feel where those springs are. And they should keep us very straight. And at this point we can press down. Do a little test here, and we can see that it's already picking up the mirror. You can see that it's nicely centered by those springs. All right. Now, the mounting tape does most of the work here, but what we're going to do is we're going to put on a retaining ring, and it's kind of a safety step. I've never seen mounting tape fail, but in the unusual case that it did fail, it's good to have a retaining ring. And the retaining ring just looks like this, very simple. Put it here, we'll line it up. These little spots here, where we screw into. It goes on like this. Now, we do not want the retaining ring to be tight. We're not going to tighten these down. It's really more just to bring it to the surface and not much more. So now we're going to secure this with 3 M3 by 10s. You could use 12s or 14s. 10s are enough. So now we have the retaining ring, 3 M3 screws partially through. Place it on. Find that first hole. And, oh. Yep, that's pretty good. That's pretty good. Maybe a little more gap on this side might be okay. Okay, good. Now our mirror is mounted in the mirror cell. Now the retaining ring will keep, and these screws will keep the mirror off of the table, so we don't have to be as cautious when turning it over anymore. So now, what we can do, we need to put our 10mm magnets in here. So, let's find 3 10mm magnets. And we look for the ribbed side, and we just kind of snap it in. Rib side in first. And now normally if we were putting a dew heater in, we would make sure that our dew heater cord was coming out where this hole is. But because we don't have that, we don't have to worry. But basically we're looking for this hole, these holes, to align with these two features here. And you can see that these tabs here line up with these little areas here. So each one of these that sticks out lines up with one of these. So The orientation doesn't matter unless you have a dew heater cable that needs to exit in that hole, then that becomes a problem. Okay, so now what we'll do is, that's right, short knobs here. And we'll screw those in until there's about 5 or 6 millimeters. They also create the ability for it to tilt. These particular ones are actually the pulling ones. They pull the mirror. And what we want to see is that there is about 5 millimeters, certainly the same amount of space sticking out on each one of these screws. That'll make collimation easier later. Okay, so each one of those is sticking out by about 5 millimeters. And now we can put in the long collimation knobs. These are the push ones, and they'll push up against those magnets. And now our job becomes tightening these. These are the push screws until all the slack on the pull screws is taken up. And when that's done, you'll feel that it's one solid body. The last part of the mirror cell assembly is the housing. And there are two different styles of housing. There's one that actually has extra deadweight capabilities where you can put extra D cells in here to counterbalance. Or it's kind of the OG, which doesn't have any extra weight on it. But essentially, other than having a place to put it's essentially an extra deadweight dock, as we call it. So what we'll do is we'll take this and we'll place it face down. And we'll take this and we'll place it on top. So now we'll line them up. So now this can just go in here. Of course, we're always careful not to scratch this front surface of the mirror. We're going to take our power screwdriver to make things go a little faster. These are M5 by 35s. All right, there you go. And now we're going to add our extrusions. We're going to be very careful not to let these collide with the mirror. 1, 2, 3, and 4. Make sure they're all seated without tipping things over. So now we need our M5 by 3030 T-nuts. These are the ones with the ball bearings in them. Makes them a lot easier to place and keep placed. And we can put our thumb underneath it just in case it wants to slide away from us. There we go. Once again. Slide it down. Glasses, I think. next step is to put these mid-trusses on. And the mid-trusses, the nose of the mid-truss always points towards the end of the telescope it's closest to. So in this case, when we're lining up this mid-truss, we want to make sure that this side here, where these heated inserts are, matches up to this side where these two mounting holes for the mirror cell cap are. We don't want it to be lined up with the side that only has this single one. So once we have that started, hopefully it'll just slide down into place like that. Okay, and it doesn't have to go all the way to the bottom. It might just slide all the way on its own. That's okay. Next piece is this other mid-truss piece, which is the same thing. And we want to line up this flat side with the previous flat side. And we want the noses, we want these pointy parts to be pointed away from each other. There we go. All right. It's kind of getting hard to see. Okay, so now that we've got those two pieces on, now we can get our baffles. So the baffles, what we want to do is we'll look for this tapered side. We're looking for this tapered side here. The other side is just plain. And we're going to point that tapered side down towards the mirror and just kind of drop it down from the top. And then just slide in just like that. And it should actually seat inside that mirror cell housing. And then the next one will actually be pointed the same way. The tapered side, this side, will go down into the first baffle we put in. Okay. So now, it's starting to look like a telescope. What we're looking for, it's one of these flat sides here. One of those flat sides is going to match up with the focuser side. So we'll bring our spider assembly, which is this fella here, and we're going to slide that right onto there as well. And you can see that the focuser is lined up with this flat side here. What we don't want to do is put too much force on all of this. There we go. This camera is really not wide enough to capture all this. Now, as we get closer, we're going to start being very careful that these little tabs on the upper baffle are all landing on the inside of of the two lower baffles. So we're just going to bring it down slowly and gently and carefully. I'll bring it down into place. Okay. It wasn't really possible to see that. Oh goodness, we need a wider camera for sure. But anyway, here's what it's starting to look like. Okay, so now, more T-nuts. Just want to make sure that there's no slack. Okay, so now that everything's horizontal, it actually is a little easier just to kind of put all the T-nuts in. We'll put one in there, put one in here, and one in here. Actually, we don't need to tighten those all the way because we're going to want to move them later. So what we'll do is tighten them and then just loosen them a bit. All right. So now, there's something that roughly looks like a telescope. So now we're going to measure from this to this. We're going to measure 60. We want to move things until we get 62 millimeters. To here. That's more like 63. Okay. All right. We're gonna call that 62. All right. So now that that rear one is secured, it's not going to go anywhere. Now what we want are these trunnions. So we're going to put these on. We'll put one to the side. We can really only handle one at a time. Now we want some M5 by 35s. They look like 35s, but we can always check how much thread there is. Yep, these are 35s. So now what we want to do is we want to see these are two pieces. So what we want to do is we want to line the holes in the outer ring up the holes of the bearing core, as we call it. So now we will line up. Started. Now, this other truss, we can just kind of slide it to line up with those screws. And all right, now we have one of our trunnions on. That's tight. That's tight. That's tight. That's tight. Okay. Wow. We have an OTA. Okay, we did it. We made our telescope. Here is what it looks like. I still have the fishing line in there, just to make sure that everything stayed where it was as we were assembling. It looks like it did. So now what we can do is we can put our red dot finder on. It's a little unit that looks something like this.